Okay, so this is going to be the first lesson in openFoam from the tutorial guide. I found it. I finally found the user's guide here. It's in CFD Direct / openFoam / user guide. If you just Google openFoam user's guide, you'll get it. And it's got an introduction, tutorials, and all this stuff. And this is how you're going to be able to go through the tutorials, right? So, uh, it has an introduction, and so we'll start with the introduction. Just as an aside, there's a lot of stuff in here that is really complicated, and I'm going to zoom over it. And so if I'm zooming over it, you don't need to know it yet. I mean, you're going to have to take fluid mechanics and figure out all the stuff related to the details of this. But for now, just copy what they're doing, right? So I go to that down to the bottom. Okay, so here's how to do the tutorials. There's this, the way that Unix and Linux works is if it's a $ and usually all caps with underscores, that means it's an environmental variable, right? So if I want to see what the environmental variable is, I go echo $foam _ run. It's Leo run. And so if I go to CD, open, and I'm tabbing Leo tabbing. There is no run directory in there, right? So I go back to home, cd and return, and back to home. So then say, okay, I'm going to make the directory this $openFoam. It knows to make openFoam / Leo -5 / run. It knows how to do that. And what's the /p thing? So if you see a Linux command like make directory, and then you see an option on that after the Linux command, and you don't know what that is, you can always do the manual for it. Man make directory. Make directory. Description, These are the arguments, right? So -m is some mode, v is verbose. Oh, here's p parents. If the parents don't exist, make the parents. That's so that make directory /p means if the directory above it doesn't exist, make the directory above it. Make the folder that it's in. And then to get out, you just say quit, Q for quit, and it gets out. That's make directory. So now I know what -p is. So let's do it. Make directory -p $foam run. So I go here and I do ls, runs there. Oh, it's there now. So the directory's there. Run. Okay. Back to my home directory. So now I'm going to follow this thing. It's going to say cd foam run. Now I want to do, let's just, for the sake of argument, let's just do pits daily first. I'm going to go through them all, but let's do pits daily first because that's the one I know the best, right? So then I'm going to copy this command. CP, so CP is copy. What's -r? R means recursive. Means copy it and all of its subdirectories, all of the subfolders that are in that directory into it. So R means recursive on that. But you can do man CP to find out all the arguments for CP as well. Copy. What's foam tutorials? Let's see if that's right. So echo $foam tutorials. Opt. It's in opt openFoam 5 tutorials. That's where they all are. So I don't want to say cp -opt openFoam 5 tutorials. I can just use this variable, this environmental variable that was set up in the bashrc file when we set it up so that we put the openFoam bashrc to make sure all the directories are known, where it executes is known, all that stuff included in that, I'm assuming, was where all these environmental variables were created. So then I'm going to cp -r $ foam tutorials / incompressible simple. By the way, it's called camel caps or something. I forget the name of it, but it's usually that the second word is all caps. That's a standard way that Linux variables are written and things like that. So that's something to get used to. So I'm going to go back because that was a mistake. See, I accidentally used the tab function there. Means to here. Copy that whole directory and all of the folders that are in that folder. Copy this folder, Pits Daily, and all the folders that are in that folder to the current directory. Dot is the current directory. So now we have Pits Daily. So I go into Pits Daily. It has the setup stuff here. So before I'm gonna skip over what's in all these folders right now and just run it. Let's just run one and get it done. And then next we're gonna do the lid-driven cavity flow problem, which is just it's just a two-dimensional flow with two fixed barriers there. All right. So first, Pits Daily. Let's just run it. And the way you run a file, the way you run anything in openFoam is you do three things: block, mesh. So what happens is you have to create it. It's all created for us, but you have to create a geometry, right? And then you have to convert that geometry to a grid, a block, a mesh, right? So you have to, and that means, you know, if you just put the edges around and say, fill it up with cubes, right? So fill this thing up with cubes so that with a finite element method, in this case, this finite volume method of fluid mechanics, is you take differential equations, you solve them numerically. Let's say you get the algebraic numerical equivalent of them at each time point, right? And each space point. So you need to solve it in a lot of different spaces and a lot of different time increments in order to be able to get an approximate numerical solution of these differential equations that describe fluid flow, right? So that's what we're doing. So block mesh makes the mesh, it makes all the grid points. So that's where we're going to solve these numerical versions of the differential equations at these points. So it's creating all the points that you can use for the solver. That's the first step. So it writes all the mesh stuff out. It gives you all this information, and then I just stopped because I made a mistake, and now I've figured out what the mistake was. So and then that block mesh is done. So then you just use the solver. In this case, the solver is a simple foam, and it runs. It's going to run for 287 of these little iterations. You can't see what's happening at each of them, but it tells you if the differential equation solver is converging. That is, if the differences between the last time step and this time step are getting smaller and smaller and smaller until eventually we have confidence that the numerical solution is sort of close to the actual differential equation solution that defines fluid flow. So 287 steps. It shows you all these things, residuals. You don't have to care what all that stuff is. And then we're gonna look at the actual results. And the way to do that is with parafoam. Okay. I'm gonna keep that up because I don't know it well enough to do anything. Okay, so it's pitfoam, and then it comes up with the raw data, all the data that's in here. All you have to do, because it's all set up, the tutorial's all set up for you, is just refresh times, and then you apply. It gives you, this is the structure. This is actually flow coming in here and then flow going out there. This is a kind of a jet. And all you have to do is just go up here and go, U is the velocity field. And then this is the first time interval, so we gave the boundary conditions at the beginning, and what's it going to look like at the end, right? So you just play it out, and boom, You can see that flow's really high here, 10 meters per second. I think it's all in meters seconds. So 10 meters per second, and here it's really low. So there's a little bit of flow right down here, but mostly it's the fluid is flowing that way. So it solved this particular thing called Pitts daily. That's it. That's what openFoam does. You create a block, you run a certain solver, it converges, and then you use parafoam to view it. That's all there is to it.